talk a little bit about a project that we did for CST337 computer architecture. We had to build a calculator using a Logisim tool. This is what we have for the project. Okay, first of all, in order for us to build a calculator, we had to use a renderer, and that was provided by the Logisim library. So this is what it looks like. So once we had that downloaded, we started building the calculator. If you look at each of them right here, each of us is a renderer, and we just had to add this right here, which is an output. So when we press on the buttons, it will display the numbers. So let me show you. So when you press 7, the number 7 will appear. Then you can reset it. So I'm just gonna go over the components of the calculator. So as I mentioned before, these are the renderers, and these are just outputs that you have to put together in order to display the numbers. We also have these are just regular buttons, and each of them is attached to a register that is 4 bits, and each of them has a constant. Like on this one, it has a constant 9 stored in the register, so when the button is pressed, it'll always display the number that it's constant on each of the registers. All these registers connect to another register, which is a selection shift register. So when a button is pressed, let's say number 9, as you can see, number 9 appears on here, and then if you go down to the main register, you can see the number 9 there, and it's also on this register right here. So when you do let's say +2 equals, the result will appear here, but it is also stored on this register as a letter, as B. So this is what we have for the register. So when a button is pressed, it gets stored on this register, and then once the operation is done, it'll be stored on this other register. The equal sign button, as you can see, is attached to this register. We also have this right here. These are just this is the adder, subtractor, multiplier, and divider. These are also part of the library. They're gonna be under arithmetic, and as you can see, these are the ones that we use for that. They are all connected to a multiplexer, which then goes to the register, as you can see. So whenever you do an operation, it'll go through here and then to this register and the flip-flop. So whenever an operation is done, it goes through here, depending on whatever you're doing, and then it'll go through these OR gates, and then the operation gets done. Let's just do little test on the when you press reset buttons, the register here gets resetted to 0. So let's do 4 minus 2 equals 2, and you can see it here, equals 2. Okay, so as I mentioned before, in order to build this calculator, we use registers, 4-bit register for each of the buttons. We use a shifter register, so it saves the output when the operation is done. This one is 4 data bits, and it stores up to 8 numbers. We also have this one, which is also a 4 data bits, and it stores 8 numbers as well. We have this OR gate, the AND gate. On this here, we have a register, which is a 32-bit, and then we also have a flip-flop and another register with a 32 bits. So whenever a button is pressed, it goes through here, and then it also uses these other two registers. This is also a 32 gate, I mean a 32-bit, and then we also have the flip-flop. So yeah, that's pretty much what we did for our project. It took us a while to finish it. I have to say that I used a YouTube video provided by the instructor as a reference, because it was almost impossible to create this calculator without any reference. Another thing is that in the beginning I didn't have this right here. I had to add it because in the beginning when I pressed a number, as you can see, it's not appearing on the screen. It states a 0. So what I did is I added this other render, and it works now just as fine. I'm not sure why is it not working without this right here, but I guess, I mean, after I added that, it worked just fine. And yeah, that's what we have for our project.